Hello and good afternoon, everyone. So the brief agenda for our webinar today is going to be, I'm going to first look at the way in which we can translate information from Revit to Trace 700. We will then look at how you can update that information and make sure data is consistent between what you output from Trace and what you pull into Revit. And the third point that we look at is to see how we can check for any inconsistencies and inaccuracies, and we'll go through that workflow as well. And we'll then close our webinar by talking about upcoming events from CTC, and we'll tackle any questions and answers that we may have at that point. So with that, let's get started with the webinar. So I'm just going to minimize my presentation here and open up Trace 700. So I have this building model, which is actually our office model that we will be moving into sometime this summer. And it's got about 123 rooms that I've broken it into. And it's got these systems here. I've went about doing the load calculation in Trace. And let me open up the calculate and view results dialog box, which will basically allow me to see the results from these load calculations. So at this point, I'll just go to view results. And I'm going to be looking for, there are a lot of different outputs that you can look for in here. And what I'm interested in is the load and airflow report. So I'll just check that box and do a preview. And on doing that, we see a report that looks like this. So we have all our space names here. So you see the name and the number for that room. And my goal here is to be able to get the information for these different rooms and more specifically get the, let's suppose the maximum supply air CFM. I want this to be populated for the corresponding rooms inside of Revit. So that is going to be our goal here. So to do that, what we'll do first on this side of the application is we will export this report out. So I'll go to export current report and I will save it to my desktop. So we have a folder here and I can just call this airflows trace 700. So I can export this report out and it's going to save it as an XLS document and I'll just hit save. So once that report is out, let's see what this report looks like. So I can close out of this and close this window as well, and I'll minimize our train application here. And in the webinar document, we have the airflow trace 700. So this is how the report looks like in Excel. So what we are seeing here is that the program automatically merges and centers these values. We are going to come back later and unmerge them. And the airflow that we are looking for is found under these columns here. So I'll just minimize this. And now what we'll do on the Revit side of the application is we will start a new project with a mechanical template file. So the template file will allow us to have the appropriate views and the appropriate categories of items turned on or turned off. And in here, I'm going to go to the Insert tab and I'm going to link in a Revit file, which is basically the architecture model that we've built for this office building. So I'll go to Link Revit and I'm going to browse to my desktop, go to the webinar folder, select this file, which is the file that we are going to link in. And I'm going to bring it as an origin to origin link. So we are going to bring it origin to origin and I can hit open and it links that file in. So once the file is linked in, one of the first things you need to do when you link files is you need to pin it in place. So I just click the pin button and that allows me to pin that link model in place. And these are, best practices that you would have to incorporate regardless of this workflow when you look at it from an MEP standpoint. So once that link model is pinned in place, I'll open up the north mechanical elevation view. And in this view, we see all the levels that are coming from the architecture model. And we also see levels that belong specifically to our model. So level 1 and level 2 that we are able to, more specifically select are levels that were embedded in that mechanical template. And so when we created a new project with that template, it brought those levels in as well. So what we are going to do now is we are actually going to line up level 2. So I'll go to the modify tab, click align, and line up my level 2 with the linked level 2. And I need to have a copy for the other levels in our model. So we'll go to the collaborate tab, copy monitor, go to select link and pick the linked file. And then the ribbon changes, and now I can click on copy, and I can copy the remaining levels so that they act as though they belong to our model. So we copy the basement level first. We can then copy the third level, fourth level, and then finally the roof level. So we have all the levels copied. Ideally, when you work in this kind of a scenario, you would also monitor these levels. Keep in mind that when you copy them, Revit automatically also monitors them for you. However, levels 1 and 2 were not copied, so we would have to explicitly monitor those levels. And that is useful in a workflow where you're getting updated files from the architects, and there is a possibility that the architects moves those levels. So in that kind of a scenario, you may want to monitor the levels as well. So we will just skip that step in our example here and hit finish. And we can see that those levels are also being monitored. Now again, I will drag this out so that we can have all our levels stacked together and all the linked levels stacked together. So we see our levels and the linked levels. And now we need to create floor plans for these levels. So I'll go to the view tab, plan views, and go to floor plan. And I'm going to create a floor plan for the third, fourth, and the basement levels. And I'll hit OK, and it creates those views for me. So at this point, I just need to rename these levels. So I can right click, rename, and then just call this B space dash space mech. I don't want to rename the level. I just want to rename the view. So I'll hit no here. And that can be done on the fourth level and the third level. Right, so we've brought in our levels, copied and created views. And the next thing that we need to do is we need to define our spaces. So keep in mind, again, our goal is to be able to get these airflows from that report to our model in Trace, to our model in Revit. I'm sorry. So to bring that, we need to have spaces to begin with. So before we actually create our spaces, we need to turn on room bounding elements in the linked model, because this is what Revit will look for when you try to create spaces. It will look for room bounding elements in the linked file. So I just select the linked file, go to edit type, and then check the room bounding box. So now my room bounding elements are turned on. And now we can go to the Analyze tab and have Revit automatically create spaces for us. So while on the first level, or level 1, my upper limit would have to be set to level 2, and my limit offset can be set to 0 feet. And with the tag on placement option selected, I can have Revit place spaces automatically. So it's now going to create these spaces automatically for me. And we can see those spaces here. Right, so let's go ahead and repeat that for all the levels. So we'll go to space, set our upper limit to level 3 now, since we are on level 2, and set the limit offset to 0, and then place spaces automatically. Okay, some of these spaces might not be able to create, and that would be, going back to the linked file and cleaning that up to get that information. So we'll just ignore those spaces for now. So on the third level, again, we'll go to space. This time the upper limit can be level 4, limit offset 0 again. Place spaces automatically. Let's actually save the file and what we've done so far in this file. And I can then just call this CTC Bloomington office. So I'll just give that a name, save that out. Then let's go to level 4, continue what we were doing. So we'll go to the roof level now, set the limit offset, and then place our spaces automatically. So we've got our spaces for all of these levels. We also need to do that for the basement. And this time the upper limit will be level 1, limit offset of 0. Okay, great. So we have our spaces created. Now these space names and numbers do not match our room name and numbers. So when I select this space and go down the properties, I see that this has a different room name and number as opposed to the space name and number out here. So to get those properties to match exactly, we are going to actually run the space naming utility found on the add-ins tab. So this is a subscription tool that you can download. If you are on subscription, you can go to the subscription center and grab a hold of this tool, and it will ask you what you want to coordinate. So we'll select the names and numbers, and we want it done on all levels. So I can hit OK there, and some of these elements may have duplicate number values. We'll just hit OK there. And now when you select any one of these spaces, you should see that the room name and number matches the space name and the space number. So that will be visible across all our levels. So even if I go to the third level, we see that those room name and numbers match the space name and numbers. So great. So we've got our model linked in, we've aligned, copy monitored our levels, we've created our views for the different floor plans, we've created our spaces and matched our space name and number to the room name and number. So at this point, we are at a good position to export the information for our spaces outside of Revit, where we will then coordinate our information between the spaces in Revit and the spaces that Trace has given us. So in order to do that, we actually have a tool called Spreadsheet Link, and this is one of our Express tools. So I can launch Spreadsheet Link, and what it allows you to do is it allows you to build a spreadsheet interface inside of Revit itself. You need not have Excel or any other spreadsheet application installed on your machine. You can do that right within the Revit environment. So you see all the Revit categories listed here, and I'm going to look for spaces and just pull that category in for now. So I pull in the spaces, and the properties that I'm looking for the space are the space number, space name, and when we have these properties here for the CFM, the corresponding property in Revit that we want to pull that information, let's assume that corresponding property is going to be the specified supply airflow. So any property that you see here as having a black font is a property that is editable, and anything that has a light gray shade on it is a property that is read-only. So Revit is automatically calculating the value of that property for you. So as you can see here, it is automatically building that spreadsheet for me as I add my columns to the application here. So we have these properties here, and what we can do at this point is we will also create an additional column here. The reason I need that column is because if you look at the output from Trace, you see that it has the space number appended with the space name as one cell value, right? So we want that same kind of formatting out of Spreadsheet link here. So you can actually create project parameters or shared parameters from the application as well. So I'll go to new project parameter, and then I'm just going to label this as space info. The parameter type is going to be a text, and I can group this under identity data. So I hit create now, and it creates a new parameter for me, which is a project parameter, and it assigns it a specific ID here. One thing I'll mention here is there are these two columns for the element ID and the family type ID. These are the properties that are read-only and are actually used by the Spreadsheet Gear application to keep track of the values when you push them out of Revit or even when you leave them inside Revit. So try not to edit these, because that would then mess up the entire purpose of this tool. So I can select this particular cell here, and I want to be able to concatenate these two columns here. So you can actually use the formulas that you would use inside Excel. So I can type in concatenate and I can fill in, so start with an equal. So concatenate this, and I want it to be followed by a dash, which I put in double quotes, and then I put in the space name. So we have that created over here, and I can then just drag and drop it just like you would in Excel, and it will concatenate all of those cells for us. Okay, so we have it concatenated, and now the format looks similar to the output from trace. Now there's another piece of inconsistency between how my spaces are labeled in Revit versus how they were done in trace, and this is something you might run into at some point. And we can see that all the values in trace have a title case, meaning that only the first letter is capitalized, the other letters are all lowercase. Whereas in Revit, we have some that are uppercase throughout and some that are title case. So just to keep the data consistent between what trace is going to push out and what Revit is going to use, what we'll actually do is we'll force all of our cells to be at an uppercase. Now you could also force them all to be title case by using another formula, but the way we'll force that is by actually appending the formula with an upper function. So that will force this to an uppercase, as you can see. And again, I can just drag that down and force all of our space info parameters to be an uppercase. So there, all of them are now forced to an uppercase, and that is something we would have to do in the Excel document as well. So before we go to that document, let's save this, save what we've done so far. So when I hit save, it will allow me to push that as a separate document, and I can then just call this airflows dash spaces dash Revit. So now it's gone outside of the Revit environment, and then it's going to ask me if I want to open this. So I'll hit yes at this point and open that document. And now we can also save our settings that we have here, and I can save that to a file, and I can then just call this spreadsheet link. So SL airflows spaces. So the settings are saved. I can close out of my spreadsheet, hit no here, and we have that spreadsheet open because we selected the option to open it right away, and we see the formulas also came through. And now this needs to be done on this application as well, on this output here. So what we'll do before we put those formulas in the spreadsheet is we'll actually unmerge all of our cells. So I'll just select one of these cells, do a Control A twice to grab the entire spreadsheet, and then I can unmerge the cells. So all my cells are now unmerged, and then these values that we have for the spaces are forced to the D column and the 16th cell in this case. So the updated values where everything is going to be an uppercase is going to be filled into the E column. And we also see that the output from trace has got some spaces that have this blank space between the value. So we also need to clean that up, because when we use a formula to tie values between this spreadsheet and the other spreadsheet, we need the values to be consistent. So you can actually use a function called trim, which will allow you to take that space preceding the text out. So what we are going to do is we are again going to put an equal, and then I'm going to force it to an uppercase, and I'm also going to trim the values. So that is the value I want to start with, and then close my brackets, and we have our output that looks like this. So again, we can do that for all of our spaces here, and we see that it cleans them up. It gets rid of those empty spaces preceding the space, and we have a good clean output from trace. So we can save this now, and now we need to somehow tie the values from this spreadsheet to the other spreadsheet, which will then allow us to pull the values inside of Revit. So the value that we want to update between the two spreadsheets is the specified supply airflow that we have for a particular space. So if I were to select this space, which is conference 143 on level 3, you have a specified supply airflow parameter. So that is a parameter that we intend to have updated through this workflow. And to do that, what we'll actually do is type in a lookup function. So there are different lookup functions you can use. The plain lookup function that is available in Excel will require that all your cells be sorted in an ascending order. But what we'll use instead is a VLOOKUP, which does not require any kind of sorting to be present as a prerequisite. So the VLOOKUP stands for a vertical lookup. So if you're doing lookup values among columns, then you would use this kind of a workflow. So I'll just type in the formula and I'll try to explain the different parameters in the formula as I type it in. So I'm telling the program now to look up for this particular value, which is found on cell F4. And the next field is the table array. So you're going to now specify what range of columns that you want the program to look for that value. So I'm going to start over here, which is the E column, as you can see in the formula bar up there. So I'm going to go from E to T, because T column is where the airflows are, and we'll just expand that column in a minute here. So I have the formula going for the cells from E to T, and the column that I'm interested in this array is the last column, which is the T column, and this T column is the 16th column from E. So I'm going to type in 16 here. Go back in here, type in 16, and then the last condition is a true or a false condition. So a true would mean that you're looking for an approximate match for the space info in the other spreadsheet, and a false would mean you're looking for an exact match. Okay, the true also tells you that it requires the array to be sorted in an ascending order, which is something we did not bother doing. So what we are going to do is actually type in false and hit enter. So when I do that, it gives me a not applicable value here, and that is simply because a one space is not found in my export from trace. So let me actually go ahead and in this document expand the T column so we can clearly see the airflow values, and that is the value that we are interested in for the space design CFM. So in the other spreadsheet, let's drag that cell and go all the way down to the end of our spreadsheet. And you see that you have an NA value for any space that it did not find in the other spreadsheet. And for this spreadsheet, we have the actual value that corresponds to the value from trace. So let's look for that 143 conference space, and the value is 330.8 here. And the corresponding value in this spreadsheet should be the same. So 143 conference has a 331 value approximately. So now we have the data connected between the two spreadsheets. Now the way this data is right now, it cannot be consumed inside Revit. The reason is because spreadsheet link is looking for a numeric value for the CFM, and this here is some kind of alphanumeric code. So we need to edit this formula here to clean up that NA and instead replace it with a 0 value. So we are going to edit this formula and tell the program that if is NA, and so if it finds an NA value, so that is my logical test, the value that I wanted to use is a 0 if it finds an NA. And if it is not an NA, then I wanted to just do the VLOOKUP function. So I'll just copy that, paste that here, and then close my if condition and hit enter, and that NA gets replaced with a 0. So that again can be repeated for all of our cells here, and it should clean up all of the NA and force that value to a 0. So now our spreadsheet is in a condition where it can be consumed by Revit. So I can just save the spreadsheet. I need not close out of this for Revit to be able to pull this spreadsheet. So I've just saved it. I still have it open. And in my Revit application, I'm actually going to open up spreadsheet link again. And I can now open my spreadsheet. So we have that airflow spaces Revit that we saved at 12:30, which should be correct. So I open that up. We see the airflows over here, and we see the values that came in from trace. It also shows you the formula up here on the command line. And now I can just hit apply, and I can apply the active worksheet. You can have multiple worksheets for multiple categories that you can pull out of Revit. In this case, we just have one worksheet, so I can do it for the active worksheet, and it'll ask me if I want to, really do that. So I'll hit yes. It'll push those values, and I can look at the import log, and it tells me that it has also created that space info parameter that we created in the spreadsheet gear, and you see the old values and the new values for your CFM. So I'll hit OK, and I can close my spreadsheet. Yeah, before I do that, let me also just, yeah, I can close this. And now if we look at space 143, the specified supply airflow matches what we had from trace. So that is a very quick and easy way in which you can ensure consistency between your data coming out of trace and going into Revit. Now, a question that might come up is, what if my calculations get updated? So that also gets taken care of thanks to the way Excel is built. So for example, if I go back to trace and go to create rooms, and let's suppose I go to space 143, we'll just focus on this one space as an example. And let's suppose that I decide instead of 5 people in this room, I'm going to just have 2 people, and I want to dim the lights from 1.2 to say 0.92. So I'll just do that, hit apply, hit close, and then I can rerun my calculation. We'll not do the energy, just do the design, and I'll hit system, and then I'll hit calculate, and it's going to go ahead and run the calculation. And we'll just make a mental note of this value, which is 330.8. We'll see that it'll have a new value now. So again, at this point, we can close the spreadsheet that we have for trace, and we can also close the spreadsheet output from Revit. So we'll just give that a minute for it to finish those calculations. And let us know if you have any questions on this workflow so far.
Yeah, Sid, it looks like we have one question that's come in so far. They're asking, what is the Spreadsheet Link program and who makes it?
So the Spreadsheet Link program is a program that CTC has written internally. We have developers that work for us and who write these programs based on requests from customers like yourself on different applications and workflows. And Spreadsheet Link is something that we see, having a universal acceptance. It has a lot of different workflows and applications that you can think of and implement. So we have it on our website. We have a free 30-day trial, I believe, that you can download, and you get all the features of the program. So feel free to just download the trial and test it out thoroughly before you make a decision. So it's still running the calculation. We'll just give that a couple of minutes.
Sid, it looks like we have one more question here. I see the calculation just finished up and we'll get going again. But is there a way to import spaces from architectural models? They avoid re-entering room numbers, names and numbers into trace.
So is the import referring to the import? Okay, into trace. Yeah, there is a way you could do that. You could do a GBXML export from Revit, and that should be able to pull out all the spaces. Now, There are some things to keep in mind when you export a GBXML from Revit. You need to make sure that the model is clean and fairly simple, so that and the spaces are defined correctly. If you remember, we went about setting the upper limit and the limit offsets. So things like that would have to be checked before you export them out, and you should be able to get that inside of trace as spaces. So it looks like we have our calculation done. So I'll just go to the load and airflow report again, go to a preview, and we see the report again. And let's look for our conference room 143 here. And conference room 143 has an updated value of 282 CFM for the maximum supply air. So we'll do that again. We'll export this out as a new report. We'll actually overwrite the existing report that we had and hit save, which will save and replace it. So at this point, we can again go back in there and open up that Excel document. And again, I'll repeat what we did earlier with this document. I'll just do a Control-A twice, unmerge my cells. So this is something you'll have to do repeatedly if you have any updates, but it's just a couple of steps, and you'll have to again just type that formula in, upper and trim this particular cell, and I need to do this for all my cells, right? And we've done this, and now we can save this document. And now actually, if I open up that output which was originally sent out of Revit, as soon as you open that up and look for that particular space, which is 143 conference, this will have that updated value filled in. And that is because it is recognizing that link to this particular file in this formula. So at this point, all you then need to do is go back to spreadsheet link and go to open and open this document again. So we should see that value down this list here, and which is for 143 conference. So we need to save this first. So make sure we save this, because if you don't save it, then it will not read that new value. So let's launch spreadsheet link again and open that document again. So it was saved at 12:38, and we see the updated value. And now we just need to hit apply and apply the active worksheet. And we'll see that it's recreated that parameter. And now if I actually close out of spreadsheet link and select 143 space, we see the updated value for the specified supply airflow. So it's as simple as that. If there are any updates in trace, you just need to overwrite the existing report, and it will automatically update the spreadsheet that is reading from that report. And you just need to re-import that spreadsheet on the Revit side to get the values updated. Now, with your spaces, there is another parameter called the actual supply airflow. And this parameter is grayed out. It's a read-only parameter. And the value that it reads is going to be based on how many diffusers you have in that space and what CFM each diffuser is set to throw out. So let's see how that would work. So if I go to systems, go to airflow or air terminal, I can set my offset value here, say at 8 feet. And there is a default value for the flow, but let's suppose I ignore that value and I place some diffusers in this room. I place them here, I place a couple over here, and let's say I place 2 in the women's restroom, 1 in the men's restroom. So we have a number of different diffusers, or a different quantity of diffusers placed in these spaces. And again, if I look at this particular space that we are focusing in, then the supply airflow is totaled based on how many diffusers are there and how much each diffuser is throwing out. So the actual supply airflow is quite different from the specified supply airflow. So what if there is a need to ensure that these values are also consistent? And what if I need to show that visually in my view here? So right now, in my opinion, there is no way to show that difference inside a view. But with Spreadsheet Link, you can actually build a parameter that calculates that difference for you and then you can create a legend view that shows that information. So to quickly see that, I'm actually going to duplicate this view, and I'm going to just rename this, and I'm going to call this 3mech and flow difference. So we can give this a name like that, and I'll hit OK, and it'll save that view for me. So we again have our spaces here, and we see that flow difference. So to actually show that in this view, I can again launch Spreadsheet link. And in Spreadsheet link, again, what I'll do is I'll look for my spaces. So it's going to go about looking for all the spaces, pull that information in again. And the properties that I'm interested in again are the name and number. So I'll pull in the number, name, and this time I'm looking for the specified supply airflow and the actual supply airflow. So we see those values tabulated here, and we see values for the actual supply airflow and the specified supply airflow. So now I want to create a parameter that will give me the difference between these two values. So to do that, you can just go to create, new project parameter, and then just call this airflow difference. Set this as an HVAC airflow and group it under mechanical flow. Right, so we create that parameter. So it does that, and now I need to define a formula here. So this is just going to be the difference between my actual and supply airflow. Now there might be instances where your actual supply airflow might be greater than the specified value, or the specified value might be greater than the actual value, in which case the airflow difference could get a negative value. And we want to avoid that, so I can type in ABS. So this will force that difference to be a positive value. It will basically get the number instead of the negative and positive symbols also. So I can put that in, and on doing that, you see that it gives you a hash value exclamation mark. And the reason it's doing that is because Spreadsheet link is reading this as an alphanumeric code. So if you subtract one alphanumeric from another alphanumeric, it will not know what to do. So the workaround for that is this little checkbox that we built into Spreadsheet link to hide the unit symbol. So on doing that, it is now going to treat this purely as numeric values. So we'll have to just make sure we do that before we define the calculated parameter, which is airflow difference, because you lose that. So just be aware that you need to check this before defining the parameter. So I'll create that again, and then just call this airflow difference. And this is going to be an HVAC airflow grouped under mechanical flow. And now let's try defining that formula again. So equals absolute of this cell minus this cell. So now it gives us a value of 0. So I need to repeat that for all of my cells here. And we should see the difference being calculated for spaces like these here, right? So with that done, I can now push this parameter back inside Revit. So I can again apply the active worksheet, and elements have duplicate number values. If I look at the import log, it creates a new airflow difference parameter, instance parameter. And what we can do is we can close out of the spreadsheet here. Now keep in mind that any new parameter that you create here will not be detected instantly over here. So it's not listing the airflow difference column that we have. So that will be visible the next time you load Spreadsheet link. Okay, so let's close out of that, close without saving the settings. And now if I look at this space, I see an airflow difference parameter that was created with the accurate value. So if I need to see any spaces that have difference between the specified and actual airflows, then I could simply create a legend, which is a colorful legend for my space, place that here. Go with schema 1 because there is no other scheme available right now. And once it creates that legend view, I can actually edit the scheme and then duplicate a scheme and then just call this airflow difference. and I can now color it based on the airflow difference parameter that we just created, which is right here. So you select that, and now your spaces are going to be colored based on that airflow difference parameter. So I can do that, hit apply, hit OK. And any spaces that have these odd colors on them, you would know instantly have a difference between the actual and the specified supply airflow. Right, so you can create legends like these also with the help of spreadsheet link. Now let's suppose you want to take this a step further and you want to have the airflow from the diffuser, from each diffuser, calculated automatically based on the specified supply airflow. Now that can also be done, and let's see how we can go about doing that. So to do that, what we'll do now is go back to spreadsheet link, and this time what we'll do is, instead of exporting spaces as a category, we will export our air terminals. So for the air terminals, I'm going to be looking for my flow. That will be one parameter that we definitely need, and we also need the space. So when you pull in space and flow, you have the columns showing this way. I'm going to sort it so that my space sits at the top, flow sits below that. So you can see that every instance of that diffuser is accounted for in this schedule, and we see the space names repeated depending on how many diffusers are placed in each space. And there are also some nice filtering functionality that you have inside spreadsheet links, so you can filter them based on whatever levels you create them on, based on whatever phase you may have, or if you have custom parameters based on which you want to filter them, that can also be done. So we have these two parameters here, and let's suppose you want to export this out at this point. So I'll just go to save, and this I'm going to call airflows dash diffusers, and this is a report from Revit. So I'll hit save, and I want to open it after it's created. So I have my third spreadsheet created this way. Now we'll again use the VLOOKUP function, but you'll see right away that in order to use the VLOOKUP function, our spaces are formatted, the space names are formatted a little differently here from the space names that we had over here. So it doesn't have the dash between the name and number, and then the name precedes the number. So what we actually need to do is we need to create a new column here, and that can also be done in the spreadsheet. If you forget to do that inside Revit, or you deliberately, have this kind of a situation where you want to create it outside of Revit, that can also be done. So I'm going to create a new column and then just call this space info, but in brackets I'm going to put in diffusers. So you need to do that, and the second important thing you need to do is you need to type in new in brackets. So this is what will allow Spreadsheet Link to detect this as a new parameter that needs to be pulled in. So you can give your parameter a name, make sure it's bracketed and called new. And I also want this column to be sitting right next to my space name and number, because remember, when you do the VLOOKUP function, you need to select an array going left to right. And since this is at the rightmost position now, I may not be able to use it. So we need to unprotect the sheet, because if I need to move columns or insert columns, that is something you would have to do. And you can password protect your sheets also. So that is the default password to unprotect the sheet. And once that is done, I can then just click in here and say that I want to insert an entire column. So it'll throw in a new column to the left. And my space info column, I just need to cut that, and I need to paste that in here. So my space info now sits right next to my space number and space name. And my space info is going to be similar to the space names over here. So it's going to have the space name followed by a space and the space number. So again, we can use that concatenate function. So I'm just going to type that in. So concatenate the space name first, followed by a space, which we have in double quotes, and then the space number. So we have that, and we also want this to be forced to an uppercase. So I'll just append the formula with that upper function. So we have something like this, and again this needs to be done for all my spaces. All right, so excellent. So we have this formula that is showing us the space names just like we have it on the output from Revit for the diffusers. And now we can use the VLOOKUP function to map the flow to the corresponding flow in the other spreadsheet. So what we'll do in fact is we are going to be creating another column here and call this total flow for space, and this again is going to be a new parameter. And now this total flow is going to actually be mapped to the corresponding flow in the other spreadsheet. So to map that, we'll again use the VLOOKUP function. So you're going to tell Excel to look up for this value, and the lookup array needs to be defined. So the array is going to go from this cell all the way down to this particular cell. So you're picking these two columns, the E and the F columns, and you're going to look for the value. If it finds a cell corresponding to C4 between these two, I'm going to pick up the value that is in column number 2, which is for the specified supply airflow. And again, I'm going to type in false because I want an exact match. And on doing that, I see the exact specified supply airflow, which is the total airflow for conference room 143. So again, that needs to be repeated for all of the diffusers that I have. And we see the values come in from that spreadsheet. Now we need the flow here to be divided depending on how many diffusers are there in that space. So for conference room 143, for example, I want 281 to be divided by 3. For conference room 141, I need 201 divided by 2, right? So to build that functionality, what we'll do again is use another formula here and then just call this equals. So the flow is basically going to equal this flow divided by a function called COUNTIF. So the COUNTIF requires a range. So I'm going to go along this range, right? So COUNTIF is going to look for this particular range, and what is it going to count for? It's going to count for conference 143. So close that and hit enter. So now it's going to nicely divide 281 by 3 and give me this value. Okay, so it's going to look for 281 and divide it by the number of times conference 143 is repeated and give you that value. So I'm going to drag this formula again down here, but now we see that we have some vague values here like 140 and 281. The reason we see those values is because when you drag and drop that function, it's going to change the cells that it's going to use on that range. So if you wanted to force it to a particular range, what you need to do is you need to force it by typing in the dollar symbol. So I'm forcing it to go between C4 and C11, and I want that to be done for all of my cells. And now the value that you see are more correctly split between the different cells. So with that done, I can now save this spreadsheet. I need not protect it again, and I can bring it inside Revit. So I'll close out of my spreadsheet link, not save the settings, and I'll go to spreadsheet link again, and I can go to open and look for my airflow diffusers -Revit. Open that. It's going to detect that new parameter that we created. And now when I hit apply the active worksheet, I can then hit yes here, and it's going to ask me to further define that new parameter that we are creating. So this parameter is going to be an HVAC airflow type of parameter, and I can put it under the mechanical flow. So create that, and if you look at the import log, it will tell you that new parameter was created, and it will give you the old values and the new values for the flow from the diffusers. So we have the new values now, and we can close spreadsheet link. And now if I select this space, you'll see that the actual supply airflow and the specified supply airflow would match exactly. So you'll see that for conference 143, for conference room 141, and you'll also see that for the two restrooms here. So the values match up exactly. One thing to keep in mind now is the airflow difference does not update automatically. So if you would like that value to get updated, then you would have to re-export the data from the spreadsheet that we had here. Or actually, yeah, you'll have to basically rebuild a spreadsheet. And this can be, a time saver if you save the settings. So I'll look for my spaces now. And remember that airflow difference did not show up initially. And that was because we were defining the parameter the first time, but now we actually see the airflow difference here as well. So look for space number, space name, and I need the specified supply airflow and the actual supply airflow. Right, so again, I'll sort them so that we have space number, space name, and my airflow difference sits way at the bottom. And this time I can tell the program that this is a calculated value. So when you do that, it will remember that when you save the settings. So save this to a file, call this spreadsheet airflow spaces, or I'll call this airflow difference for my spaces. Save that setting file. And since it's a calculated value, you can simply just go in here and say that it is the absolute difference between the value in this cell and the value in this cell. And yes, you need to hide the unit symbol before you do that. So let's do that again, redefine that formula. So equals absolute of F4 minus E4. And I actually need not have to drag that cell. Since it's a calculated value, the program understands that the value that you put into the first cell is what gets pushed down that road. So all of the other cells will automatically read that difference. And for conference 143, let's look for that, or even 141, that difference should now be 0. So that value has now got updated. And now I can apply this worksheet, close that, and close out of spreadsheet link. We've already saved the settings, so I can hit no here. And then you can see that the airflow difference for this space goes to 0. So that's how you can go about updating the spaces so that the airflow difference reads a value of 0. So this workflow would work well even if you were to now go in trace and make some other edits to your spaces. So if you were to close that report, go to trace and make some other changes to your spaces, since all of those spreadsheets are linked together, you just need to update the airflow trace report in this case, and all the other spreadsheets would update automatically, and you would just have to then bring those reports inside Revit. So do we have any other questions?
Yeah, Sid, we have some good questions coming in here. Someone is asking if we teach classes on this workflow and they could use their specific files to show these features.
Absolutely, we could develop workshops just like we have a webinar. We can certainly do a workshop that would focus on specific families you may have, maybe for the diffusers. And yeah, we are definitely open to that kind of a scenario, because that would also allow us to learn new and better ways to do these things if that can be done.
Okay, thanks. And then another person was wondering, does this workflow work for pipe calculating and the flow and size calculating?
Yes, this can also be done for the pipe flows. One thing with pipes is that you need to make sure they are connected correctly and the flow propagates correctly, which would mean that if you have custom families defined, you need to make sure that the flow configurations are set up correctly. But you should be able to use this for a piping calculation also. Again, keep in mind there are read-only parameters that you cannot edit. That is just something that Revit locks down. So we cannot do that even with a spreadsheet gear. But if there are custom parameters you create and you want to, get that kind of synchronization, it can certainly be done.
Okay, thanks, Sid. And then one more question here. What is the workflow for updating space information from Revit to the Excel worksheets when the room and space names and numbers change, as they often can?
That's a good question. So, workflow for updating space information when the room names and numbers change. So that can be done in a similar way. Um, I mean, if you're using something like the space naming utility, you could just run that utility again, and your space names and numbers would update automatically. But if it is this kind of a scenario where your space names and numbers in trace need to be updated first, based on what names and numbers Revit is using, then that would be more to do with that particular application and seeing if there is a way that it can take in an input from something like a spreadsheet. So in that scenario, you could push out a spreadsheet from your Revit architectural model and somehow tie in the information to another spreadsheet that would link up with trace. But that is more a question for trace, and if they have some sort of a workflow for that.
Okay, thanks, Sid. And we'll keep on the line here and have questions come. Thank you.